Here is a simple example of IDS, iterative deepening search. So it's basically the same as DFS. So we're going to use stack to keep track of things. And the only difference is we're going to search depth 1 tree first and then depth 2 tree and so on. So when you actually implement this, you should not draw the tree. But when you are solving a non-exam, I think it's easier to draw a tree. So you start with initial state 1, and then it's 2 and 3. That's the first level tree. And 2 has 2 successors, 2 times 2 and 2 times 2 plus 1, 4 and 5. 3 is 6 and 7, and 4 is 8 and 9, 5 is 10. So when you draw a tree like this, it will be very simple. You don't need to keep track of the depth. So you do DFS on this subtree, and DFS on this subtree, and DFS on that whole tree. So there is the problem that in the lecture I didn't do DFS for the zero depth tree. It's really up to you. So I'll use the convention that you do not do this. This is a waste of time. So I'll assume you start with this tree like this. So you're going to do DFS. So let's keep track of the expansion path or expansion sequence. And to do this small tree, so I'll just push 1 and then pop 1 and then push the successor 2 and 3 and pop 2, pop 3. None of them are the goal. So you pop 1 and then you pop 2 and then you pop 3. So that's the level 1 expansion pass. And you do the same thing. Let's change the color for level 2. So this is depth restricted to 1. Actually, less than or equal to 1. And when you have depth restricted to less than or equal to 2, then you have first start with 1, pop 1, you get 2 and 3, pop 2, you get 4 and 5, pop 4, you don't get anything because you are restricting to this small tree here, pop 5, you get nothing, pop 3, you get 6 and 7, pop 6, pop 7. So I forgot to keep track of the order, but basically it's 1, 2, 4, 5, and then 3, 6, 7. So that's for depth 2, and for depth 3, you just copy from DFS. So copy from DFS because it's just searching through the whole tree.